Hey guys, Miss Carrie here to talk about rhombuses or rhombi. So remember our mother of all quadrilaterals is the parallelogram. So of course we're going to use that as our basis for every other parallel or for every other quadrilateral. So let's read here. We see that rhombi have the same properties as parallelograms. Okay, so if we know the properties of parallelograms, we just can apply that to another four-sided figure called the rhombus. Okay, so we still have opposite sides are congruent. We still have opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary, and diagonals bisect each other. So what's new is these three things. One, all four sides are congruent, kind of like a square, right? So all four sides are congruent, meaning that it's going to be equal no matter what side we're looking at. We also know that diagonals are perpendicular. Perpendicular means hit at a right angle for anybody who does not remember that. So that means they hit at a right angle. This is 90 degrees. Okay, so that's perpendicular for those diagonals. Okay. And number three, diagonals also bisect opposite angles. So they actually bisect means cut in half. So the diagonals cut each angle in half. Okay, so we're going to see that up. I'm just going to start with number one, see how far we get. I got a couple that I do want to talk about, but we can just start with number one. Okay, all right. So JK is 12. So J to K is 12. It tells me right there, and JN is 7. Okay, all right. So that we'll just start with JK. Well, JK tells me um, that all of the sides are 12, okay? Because I know that all four sides are congruent, right? So all four sides are 12. Should be pretty simple, right? So I know JM is 12 and MNMK. Nope. So that's the only one I know as of right now. Okay. All right. I also know that the diagonals bisect each other. See, that's one of our rules of the parallelograms, that diagonals bisect each other. So point N is an important point because it's the midpoint of those two sections, meaning that 7 right here is half of that total length, meaning that the other side is also 7. Okay. That's pretty easy to find JL. J to L is 7 plus 7, which is 14. All fine and dandy. But now I ask you to find MN, and MN is right here. And the second one tells me to find is the total of MK. Okay. I want to remind you guys about the first, or not the first, but the second little factor that we learned up here, that diagonals are perpendicular. So I'm going to mark this image with the diagonals being perpendicular. There's a right angle right here. Okay, the right angle right here. All four of these angles are right angles. Okay, all right, so all four of those are 90 degrees. Okay, and so remember how in rectangles, how we had those 90 or those right triangles inside the rectangle. Well, we also are going to have right triangles inside of a rhombus, and I'll show you exactly where they are. Okay. I'll highlight them for you. Right here. Here's a right triangle. Okay. If I draw this triangle out here, I'll have one side that is 7, and I know the hypotenuse is 12 because it's opposite of the right angle. Okay, and so they're asking to find this missing side. As I said, we should be able to see, if we know we have right angles, we should be able to see those right triangles and solve using the Pythagorean theorem. We should get something like x squared plus 7 squared equals 12 squared, and solve for x. At this point, you should be able to solve the Pythagorean theorem. So I'm just going to go ahead and tell you x is 9.7. If you don't know how to do the Pythagorean theorem, you should use Google and look up a YouTube video that you'll listen to better than me, because I have taught it a bunch of times, and today is not the day to teach Pythagorean theorem. Okay, a squared plus b squared equals c squared. Look it up. Okay, but I do know x, or that missing side, is 9.7. So you have to use the Pythagorean theorem to solve for a missing side of a right triangle. Okay? MN is 9.7. That's fine and dandy. Then they asked me to solve for MK. MK is the total length of the diagonal. So what am I going to do with that 9.7? You guessed it. Diagonals bisect each other. Okay? So the diagonals bisect each other. That means that they cut each other in half. So half of my diagonal is 9.7. So to get the whole thing, I just got to do 9.7 plus 9.7, which is 19.4. And that's how you solve for it. Okay? I should be able to do number 2, so I'm going to jump down here to number 3. All right, RT is 22, so that total length from R to T is 22. I know that diagonals bisect each other. If you don't believe me, go look back at your notes. So these get cut in half at point B. So RT is cut in half at point B, so that means I have a side of 11 and 11. 22 split into 2 parts is 11, okay? I also know that US is 18. US is 18 in total length. And so once again, diagonals bisect each other, so it gets cut in half here at V. And so 18 is split into 2 parts, 9 and 9. Okay. I also know that I got right angles in here. So I've got 4 right triangles. 1, 2, 3, 4. Show you that again. 1, 2, 3, 3, 4. Okay. There are 4 right triangles in here, whether you like it or not, that there they are. Whether you believe me or not, that there they are. Okay. So the length of VT is 11, because I already know it's split into those 2 parts, 11 and 11. UV is 9. RS is the length of the side right here. So it's the length of this side. Well, I happen to know I have a right triangle right there with a side length of 11, a side length of 9. And the hypotenuse is always opposite the right angle. So I'm looking for that hypotenuse. Once again, Pythagorean theorem will solve for a missing side of a right triangle. For this case, it would be 9 squared plus 11 squared equals x squared or c squared or whatever you put there. That's you got to solve for that missing side. And I happen to have the inside knowledge that x is 14.2. I'm not doing the Pythagorean theorem for you guys. You guys should know this already, once again. So I encourage you guys to work that on your own to make sure that I'm telling the truth, which you guys obviously know I am. But you guys can look up a video on how to do the Pythagorean theorem if you do not know. It's good. I don't know what to do. I'm going to look it up. All right. So I know R to S is 14.2. Okay, and I also know that all these sides on a rhombus are congruent. So let's see what it asked me for next. It asked me for ST. I know ST is going to be 14.2 because all of those sides are congruent. All right, now let's talk about these angles. It's one of my favorite parts about rhombuses. Okay, so I would encourage you guys to go back and look up here. Okay, let's just review what the angles say, what we know about angles. So opposite angles are congruent. Consecutive angles are supplementary, and the diagonals bisect opposite angles. So they cut those angles in half. Okay, so I'm going to mark this rhombus with what we know. Okay, so I know opposite angles are congruent. That means this one over here and this one over here are going to be the same measure. Okay, same for the other 2 opposite angles. Great. We know that to be true. I also know that consecutive angles, meaning these 2 on the bottom, are going to be supplementary, meaning if I take this total angle and this total angle, they will add up to 180 degrees. Okay, I need to know that information for later. But the most important thing that I want you guys to know is that the diagonals bisect these angles. So this diagonal right here cuts this angle in half. That means that it's going into 2 equal parts, okay? So that means that if this angle is 38 degrees, well, then angle 3 is also 38 degrees. If this angle 1, angle 2 are congruent, angle 4 and angle 5 will be the same as 3 and this 38, because opposite angles are congruent. I just talked about that. Opposite angles are congruent, right? So that means that those are going to be the same. And angle 6 and angle 7 will be congruent to one another as well. Okay, so automatically off the bat, I know that 38 degrees is also going to, angle 3 is going to be 38 degrees, and angle 4 and angle 5 is going to be 38 degrees. Once again, because the diagonals cut the angle in half, that whole angle splits it right down the middle. So both of these are 38 degrees. And this is the same for every rhombus. This is how it's going to play out. I'll highlight all these yellow angles for you. If you guys like the colors, that works too. Okay, so all of those are going to be 38 degrees. All right, now this is when we need to know about those combo or supplementary angles. These ones that share a side are supplementary. So these two right here are supplementary, meaning they're going to add up to 180. Okay, so this total yellow angle is going to be 76. This total yellow angle, these ones right here are both 76. Okay, all right, so if this total angle is 76, then I know these two added together will be 180. Then what I got to do is find the difference between 180 and 76. So 180 minus 76 is going to be 104. That means this one's 76. This one has to be the difference between 180 and 76. So this one is 104 degrees. You might be thinking, Miss Carrie, how does that help me? I have two angles. Well, we know those angles are split into two equal parts, or that angle is split into two equal parts. So what are equal parts of 104? Well, I'm so glad you asked. It's 52. 104 divided by 2 is 52. Therefore, I have just confirmed that angle 1 and angle 2 are 54 degrees each. So, and I will highlight them for you since you guys like these colors. These ones over here too, because we know opposite angles are congruent, and we know those alternate interior angles are also congruent. So these two angles are 54 degrees because this whole thing is 104 degrees, as shown by what I did right here. And these are also 54 degrees as well. If you notice, those alternate interior angles here and here are congruent still, so all of that still plays out. So measure of angle 1 is 54, measure of angle 2 is 54, and then 6 and 7 are 54 as well. Okay, but the one you might not know off the bat is number 8. But you should know that rhombuses have diagonals that intersect at perpendicular angles. So what do you think that angle right there is going to be? Okay, it has to be 90 degrees. Okay, hopefully you were paying attention. And that's how the angles in a rhombus behave. Okay, so you should be able to do number 2 and number 5, and we will talk about squares next. Okay, extra credit for this video is tell me the origin of the name rhombus. Where did it come from? Why is it called a rhombus? Okay. It's not like parallelogram where it makes sense with the two pairs of parallel lines. What is the origin of a rhombus? And give me an example of one in real life.